Okay, we finished 2D shapes. Now we're going to move on to 3D shapes. Right below you see the pyramids at Giza and the Sphinx. Those are one of the wonders of the ancient world. And in case you're wondering if this stuff is relevant, it certainly is. One of the problems with it is I can't draw it very well using the software I have. So there may not be as many examples as I would like. I usually would bring in items to a class to illustrate some of these shapes and to show it more clearly. They tend to be fairly difficult to draw too on a blackboard or whiteboard. But we're going to get into it and I'll do my best. Alright, so there's rarely that many questions, but you have to know which formula for which. The shapes on the exam are the cylinder. You might see one of those. The pyramid, the cone, the sphere, the rectangular prism, and the right prism. Usually the two kinds of shapes that tend to show up are the cylinder and either the rectangular or right prism. Those are fairly common, and occasionally the cone. You don't see the pyramid and the sphere as much, and they tend to be confusing and reasonably difficult to draw. Okay, surface area and volume confuses people sometimes. Surface area is how much material it would take to cover the surface of the shape. Think about gift wrapping an object. Okay, like you wrap a present for Christmas. Think about surface area like that. It's like spreading Christmas gift wrap paper across a shape. That's what the surface area is. You're covering the entire surface of a shape, a three-dimensional shape. So it's kind of like gift wrapping paper. Volume is how much the shape could hold. So the volume of a milk container is usually a gallon in the United States. The volume of a 2-liter bottle is 2 liters. Volume is how much is or could be contained in something. Okay, sometimes it helps to visualize these things. The first one we're going to review is a sphere. A sphere is like a bowling ball. It's a circle in 3 dimensions. The surface area and volume of a sphere, it's a bowling ball or 3D circle, the surface area is 4 pi r squared. The volume is 4/3 times pi r cubed. Okay, and the radius is the same as on a circle. You go right to the center, and it's a line that goes outward. Okay, a pyramid, like those pyramids at Giza we saw at the beginning, one of the wonders of the ancient world in Egypt. A pyramid, though there's other kinds of pyramids, we'll stick with that kind. The surface area and volume of a pyramid is, the surface area is 1/2 of the perimeter of the base area times the slant height, which is the slight from the angle to the apex, the top, plus the base area, the area of the bottom part. This is a little confusing. So I was sure to diagram that stuff out so you get a better idea. The volume is 1/3 of the base area times the height. Okay, and that's the regular height, like with the triangle, from the bottom of the figure to the apex, not from the not the slant height, which is the angle, the bottom of the angle to the apex. Excuse me. Is different types. That part won't be on the test. The different types won't be on the test. I mean, the surface area and volume could be. You are given these formulas on the exam, but you will have to recognize which one applies to which shape. Okay, I'm giving you a problem. The left period has a slant height of 15, a height of 10. The side of the base is 8. So calculate the surface area and volume. We're going to run through one of these. Okay, you remember you could press spacebar at any time to pause the video. And why don't you do that right now and solve the problem, and we'll be back in a moment. I'll give you 1 second to do that. Remember, spacebar to pause. Okay, we're back. So first the surface area. Surface area equals 1/2 32 times 15 plus 8 squared. Okay, so 16 times 15 equals 240 plus 64, 304 units squared. And remember, we got that. Remember for B, what B was? Okay, let's look at B. B is the base area, the bottom part area. And the bottom part was a a square in shape, so it's 8 squared. That's where we come up with the 64. Okay, and we multiply through the volume, 1/3 64 times 10. Remember, the volume is 1/3 the area of the base times the height. So we already figured out the area of the base was 64 times the height, which is 10. So 1/3 64 times 10, 213 and a third units. Either the surface area or the volume can be greater. The two are incommensurable. That means you can't compare them. So don't be too worried if your surface area is larger than your volume or your volume is larger than your surface area. Cone. Cone. It's like an ice cream cone, or you could flip it the other way around and it looks like an upside down cone or a dunce cap. The surface area is pi r slant height plus pi r squared. Okay, and the slant height is, again, it's the angle. You look at the bottom left-hand picture, the angle of the cone. It's like if it was a triangle, what would the angle be from the apex, the tip, to the base? Okay, you go straight down the side. You may have to draw an imaginary line to do so. But they'll probably give this to you. The volume is equal to 1/3 pi r squared height. And the height is from the base to the apex, to the tip. Okay, that's 1/3 pi r squared h. That's the volume. Okay, let's do a right prism. Prisms tend to show up a decent amount of time on the exam, so be mindful of this one. The surface area of the prism is the perimeter of the base area times the height plus 2 times the base area. So let's look at the perimeter of the base. Okay, that would be the area around the base. This kind of makes sense when you think about it, because remember, surface area, it's like what would it take to wrap something? So when we come up with this formula for the surface area, we go, okay, the perimeter, okay, times the height plus 2 times the base. The reason why is, okay, 2 of those sides are kind of equal, right? Yeah, all right. And the perimeter of the base, okay, that makes sense, times the height. All right, this kind of makes sense when we look at this problem, right? And a right prism has a triangle built into it. So it's kind of figuring the depth of the right triangle using this. The volume is the base area times the height. Okay, so there's some more pictures there to clarify some more. The surface area and volume of we just did a right prism. Now we're going to do a rectangular prism. The difference is this has a triangle as part of it. So it's almost like it's half of a prism. This is a rectangular prism. It's in a rectangle in shape. This is a lot simpler. Think about this like a rectangle in 3D. The surface area is 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. The volume is length times width times height. It's pretty straightforward. So if we look at the figure at the bottom, that's 15 by 3 by 3. The volume is 15 times 3 times 3. The surface area would be 2 times 15 times 3 plus 2 times 3 times 3 plus 2 times 15 times 3. Okay? So that's pretty straightforward. The cylinders tend to show up a decent amount of time. They may show up in the form of a can or something. The surface area and volume of a cylinder is, surface area is 2 pi r h plus 2 pi r squared. Okay, so what it's doing, it's kind of taking the circle and extrapolating that into figuring out a 3-dimensional version of that, a cylinder. It's like a can that a frozen, a fruit salad can or soup can or something of that nature is a cylinder. The volume is pi r squared h. So that's really straightforward. The volume's a circle, pi r squared times h. Okay? And since a circle's part of it, that makes sense. A lot of times on the exam for the questions, they'll have 2 overlapping cylinders. So it'll be like a cylinder that's not filled all the way, let's say. And you have to figure the difference in liquid or the difference in volume or something of that nature. I couldn't figure out how to draw it, but something like that is fairly common. So you may see something to that effect. So that's why it's important to be able to figure this out. What you're going to be doing is, it's a lot like When I get into tips and tricks a little later, I'll show you with the rectangles, but they like giving L-shaped formations of rectangles on 2D shapes. So you got to kind of figure, okay, this is really 2 rectangles. With the cylinders, they do a similar kind of thing, where you basically, it's a cylinder that may not be filled all the way, or you may have to figure the difference in volume or whatnot. So you're basically dealing with 2 cylinders, okay? So be mindful if you see something that looks like a can, you may have to start looking for that cylinder shape. Okay, so just remember, the formulas for this are going to be available to you on the test, so don't focus too much on memorizing the formulas. Focus on knowing which formula applies to which 3-dimensional shape. Okay? And I'll see you in the next lesson.